we're going to go ahead and get started. Technically, this is a new lesson, but in practice, really, we know how to do all the things we're going to do today. Okay? We are going to be multiplying polynomials by polynomials. We multiplied polynomials by polynomials yesterday. We multiplied a binomial times a polynomial. So, for instance, here, a monomial times a binomial, right? A monomial times a trinomial. So yesterday, technically, we did multiply polynomials by polynomials. Today, we're going to be multiplying not just monomials by 2 and 3 term expressions, but we're going to be multiplying binomials times binomials. How many terms does a binomial have? 2. How many terms does a trinomial have? 3, right? So we are actually not going to multiply a binomial by a trinomial today. We're going to save that for tomorrow. You'll notice on your homework tonight, you're only multiplying 2-term polynomials by 2-term polynomials. That's binomials times binomials. With me? Okay. And the way that we multiply any polynomial by any polynomial is use a distributive property, just like we did yesterday. So we're going to use a distributive property to multiply all terms. Then we're going to combine like terms. So anything that can be combined, we're going to combine that. And then at the end, we're going to make sure it's written in standard form, just like we did yesterday. And as a reminder, anybody remember what it means to write these expressions in standard form? What's it mean to write it in standard form? Do you remember, Lee? You remember, Brandon? You put it in our notes yesterday. Do you remember, Akira? So you're on the right track. It's greatest degree to least degree, right? So we want the term that has the largest sum of exponents on the variables first, and the one that has the least at the end. So we say we're writing them in order from greatest degree to least degree. Jaden, we're writing this. So we're just going to go through and do some examples. Everybody caught up with me? Anybody need me to move this over from greatest degree to least degree? I'm going with, did everybody caught up with me? Anybody need me to go back? Alright, so we're looking at this first example, example 1. First of all, I'm thinking about, let's cross this out. The directions on your assignment used to say using a table, but I took those directions out, so just scratch out this part. That part would just be confusing. So this says simplify each product using the distributive property. We're going to do all of ours using the distributive property. The distributive property just says if you get something on the outside of the parentheses multiplied by something on the inside of the parentheses, make sure whatever's on the outside, you multiply by everything on the inside. Now we have 2 sets of parentheses, but we can treat each of these in the first parentheses just like we treated things on the outside of the parentheses. For instance, we are going to multiply B by everything in this parentheses. Then we'll multiply negative 2 by everything in these parentheses. So we're going to start, we're going to distribute the b to b. That means b times b. What is b times b? Say it loud. B squared. And what's b times 1? That's right, it's b. So we've now distributed this first term in the first binomial to everything in the other parentheses. So now we're going to distribute the negative 2. It's going to be multiplied by everything in the second parentheses as well. What's negative 2 times b? Okay, Sean, what's negative 2 times b? Perfect. And now negative 2 times 1. What's negative 2 times 1? Brandon? Negative 2 times 1. Yes, what is negative 2 times 1? Yep, negative 2. So the first step said we multiply using the distributive property. We did that. The second step said we're going to combine like terms. There's a b squared here. Remember, like terms mean same variable, same exponent. There's not another b to the exponent of 2, so we're just going to bring that one down. Now we have b to the first exponent minus 2b to the first. So those are actually like terms. So those can be combined. And the way we do that, remember, is we either add or subtract their coefficients. What's the coefficient on b, Anson? Yes. So that's 1b minus 2b. So we do 1 minus 2. That gives us negative 1b. And we just write that as negative b. So we're done with those. There's nothing to combine as a constant, no other like terms. We just bring that down. So that's step 2. Step 3. We're going to write it in standard form, or check to see it may already be in standard form. What's the degree on this b squared term? What's the degree on that term, Jeremiah? No? Yes, the exponent on the variable is 2, so that's the degree of that one is 2. What's the degree of the negative b, Kendall? Perfect. What's the degree on negative 2, Lee? 0. Very good. There's an exponent of 1 on negative 2, but we don't count those exponents on constants, so we say the degree is 0. So this is already in standard form because it's 2, 1, 0. Greatest to least. So that's our final answer. Any questions? All right. Let's go on to example 2. Same thing. The first term in the first parentheses gets multiplied by both in the second. What's x times x, Brooklyn? What's x times x, Zion? Yes, x to the second power, or you can say x squared. What's x times 5, Corey? Sorry? X times 5 is 5? 5x, right? X times 5 has to be written as 5x. Okay, so we've distributed the x to everything here. Now we've got to use the distributive property and distribute the 6 to everything here. So Corey, what's 6 times x? Perfect. What's 6 times 5? So we're distributing that 6, the last term. What's 6 times 5, Swan? Yes. They're both positive, so it's a positive 30. So the x squared, I have nothing I can combine it with, so I'm bringing that down. 5x and 6x, they're like terms. What is the sum of 5x and 6x? All right? Perfect. So we've taken care of those. And we don't have anything else to combine with the constant, so that is our final answer. Once again, degree of 2, degree of 1, degree of 0. So this is already in standard form. Any questions? Okay. Example 3. Still not doing anything different, but this does look a little different because there's a coefficient on the t here, right? But it doesn't matter. This first term gets multiplied by everything in the second set of parentheses. So 2t times t, what's 2t times t, Brooklyn? What's t times t? Okay, so I just asked you about x times x, right? And you were a little confused. I forget who told you. I think maybe Lee told you x times x is x squared, right? If x times x is x squared, what do you think t times t is? Yes. But it's 2t times t, so it's 2t squared. What's 2t times negative 5, Jacoy? Sorry? 2t times negative 5. Yep, negative 10t. Alright, so the 2 has been distributed to everything in the second parentheses, so now we're going to do this negative 7. What's negative 7 times t, Jaden? So negative 7 times t. What's negative 7 times t? Negative 7t, right? It's negative 7 times positive t, so negative 7t. Notice you don't see there's a 1 on that t, right? So it's always number times number and variable times variable. Kendall, will you put your backpack down? And now it's negative 7 times negative 5. What's negative 7 times negative 5? Fatima? Negative 7, we're distributing the negative 7. What's negative 7 times negative 5? Perfect. So nothing to combine the 2t squared with here. There's no other variable to the exponent of 2. Now these both are t to the first power, so those can be combined. Negative 10 minus negative 10t minus negative 7t. Remember, we combine those by adding or subtracting the coefficients. This is the subtraction, so we subtract negative 10 minus 7. If you do that on your calculator, it's 10 negative button minus 7, and that would give you negative 17, and we see that it's negative 17t. So we've included all these in our answer. There's nothing else to combine the constant with, so we bring it down. Degree 2, 1, and 0 again, so it's already in standard form. Any questions? So did you notice that every time we multiply a binomial times a binomial, we'll get a trinomial? Binomial times a binomial simplifies to a trinomial. Same way here. That is not always the case, but most of the time that is the case. So this next section, one of these is not going to be that way. Let's start with example 4. What do you think we're going to do first in example 4? What do you think we're going to do first in example 4? Akira? Very good. Distribute the 3z to the 7z. That means you're multiplying them. Number times number, 3 times 7 is 21. Z times z, we have to know that's z squared. What do we do next, Keishan? Perfect. So when we write negative 15z, it's minus 15z, right? What do you think we do next? Anson, do you know what we do next? The negative 4, that's right. So it's going to be negative 4 times 7. It's negative 4 times 7. Well, number times number. If you want to do it on your calculator, it's 4 negative times positive 7 plus. It is negative 28. So it's going to be minus 28, but don't forget the z. And what's the final step that we're going to do here, Brandon? 4 times negative 5. If you're stumped, do in your calculator 4 negative button times 5 negative button. You should get a positive 20. Okay? Not in the final form yet because you have 2 terms and a z to the first power. Okay? So nothing to combine this one with, so this one gets brought down. And if I have a multiple terms, I just always like to cross them out, so I make sure to include all these terms in your answer in some form. So now, like terms times like terms, these can be combined. To combine those, what's that going to be if we combine negative 15z minus 28z? Lee? No. Negative 43z, yes. Remember, negative 15 minus 28, it's not minus a negative, right? Negative 15z minus 28 is negative 43z, so we've included those, and we don't have anything to combine that with, so that is our final answer. And it is in standard form, so these we don't have any that you have to rearrange around any of these examples, but you very well may have some in your homework you have to rearrange to make sure they're in standard form. So you might imagine that example 5, a binomial times a binomial, this is going to be the exception to the rule. I told you a binomial times a binomial is almost always a trinomial, but not in this case, so let's do it. What's the first thing we're going to do here, Kendall? Yes, 7h times 7h. That's right. We're distributing that first term here to the first term there. What's 7h times 7h? What's 7h times 7h, Jeremiah? 49h. Does it have an exponent on it? Yes. Remember, you add h's, you don't change the exponent. If you multiply variables, you have to change the exponent. H times h is h squared. Now we're going to do 7. We're going to distribute the 7h to the negative 6. Number times number, negative 42, but we can't forget our h. Not h squared here because we're not multiplying it by another h, right? So what do you think we do next? What do we do next, Fatima? Okay, so tell me what to do. Okay, tell me what to multiply. Well, we are actually going to do that, but let's do it in order, right? Let's do the 6 times the first term first. Technically, the order wouldn't matter. You could have done that, right? But we're going to try. I find if you do things the same way every time, your strategy is to repeat that same pattern, you're more successful. So 6 times positive 7h, positive 42h. Now we're going to do your 6 times negative 6, so that will be minus 36. Yes. So nothing to combine the 49h squared with, so we're bringing it down. Now, what is a negative 42h plus a positive 42h? It's 0, so we could say that it cancels out, right? 42 negative button on your calculator plus 42 equals, you'll see that's 0. So we don't put any of that down there because that does cancel out to 0. Minus 36, that's your final answer. Binomial times a binomial, in this case it's a binomial. See you tomorrow.